Hi everyone. Pretty simple topic for this lesson, for this video, and it's just simply the interior and exterior of circles. So let's pull up a circle here. I'm going to actually use my circle tool, so I get a nice one you don't have to put up with my artwork. And I'm going to make this inside of this circle green. And maybe, let's try that again. There we go. So right here I've got a green section inside. So the interior of the circle is what this section is in green. And we say the interior of the circle is the collection of points in a plane, oops, in the region bounded. Bounded just means to close in by the circle. So when we talk about the interior, we're not talking about just the, I guess, the area. We're actually talking about the points that are inside of that is where we want to go with this. So of course there's infinitely many points, but we would say that A is in the interior of the circle. B is not in the interior. So instead, if it's not in the interior, well, we end up with this other region, which is the exterior. So the exterior of the circle is the region outside the circle. Yeah, keep it simple. Sure, we could come up with a more formal definition, but that gives us the idea. So B is in the exterior of the circle, A is in the interior. And just a refresher from geometry, if we want to name a circle that isn't on a coordinate plane, so we can't find its center point, we of course name our circle by its center point. So we could say the circle centered at C right here. So A is in the interior of the circle centered at C, B is in the exterior of the circle centered at C. Okay, well, how do I come up with an equation that is going to determine interior, exterior of a circle? Well, I'm going to do that with an inequality. And the way I'm going to do that is I'm going to start off with our equation for a circle. So x minus, I'm going to come up with just a random one here, x minus 5 squared plus y minus 2 squared equals 9. So we've got the circle centered at 5 comma 2 with a radius of 3. Okay, so there's my circle, but I don't just want the circle, because what this tells me is this actually tells me the boundary, the points that are all the same distance. I really want the interior, so I want all the points inside of that region that's bounded by this. So in other words, I want, if I draw just a quick sketch over here, my circle might look like this. I want all these points inside. So I actually want all the points that are less than or equal to 3 units away. So I'm just going to change that up a little bit. X minus 5 squared plus y minus 2 squared is less than or equal to 9. So what this tells me is it's all points less than, our radius is 3 units, or exactly 3 units, because of the or equal to, from 5 comma 2. And that's how we get the interior. And if we want the exterior, very similar. We just switch it up. X minus 5, that quantity squared, plus y minus 2, that quantity squared. And that would be, if I wanted all the points in the exterior, I would say greater than or equal to 9. All right, let's go ahead and get some actual graphs of these so we can see a little bit better what they might look like. So let's pull up a coordinate plane here. Alright, let's see if I can get that other piece to show up. Doesn't look like it's going to let me show them both at the same time. Okay, so let's write over top here. X minus 5 squared plus y minus 2 squared equals 9. So I want to stick with that same equation. Okay, I'm going to change that up. I'm sorry. I'm going to go back to my greater than or equal to. So what this tells me is I've got two pieces. I've got all the points that are exactly my radius, 3 units away. Okay, so let me get my center in here. Let's get some labels. Okay, so I've got my center point is 5 comma 2. 5, 2. There we go. There's my center point. 3 units away, so it looks like I'm actually going to be off my grid here, but that's okay. We'll estimate it as best we can. So about there, there, 1, 2, 3, 2, 3. Now, if this were equal, we know that we'd have the boundary and just the boundary, and we'd be set there. Okay, but that's not the case here. We don't have just equal to. We have greater than or equal to. So I want to show you what actually happens with that. So let's see. Let's say if I pick a point on my circle. Looks like this point I've got 1 comma 2. So I'm going to put 1 in for x and 2 in for y. 1 minus 5 squared plus 2 minus 2 squared greater than or equal to 9. I'm sorry, I did that backwards. Or I had my point wrong. I looked at my point too fast. Sorry about that, guys. That's not 1 comma 2. That is 2 comma 2. Let's fix that up. Okay, so let's try that again. Let's put in 2 for x. 2 minus 5 squared plus 2 minus 2 squared. We want to see if that's greater than or equal to 9. Okay, so 2 minus 5, that's negative 3 squared plus 2 minus 2 is 0 squared. Well, negative 3 squared is 9 plus 0 squared is 0. Yeah, 9 plus 0 is greater than or equal to 9. It's equal. So that's my boundary, the or equal to. Okay, let's try a point in the exterior. And I'm going to go real easy. I'm going to try 0, 0. Okay, so 0 minus 5 squared plus 0 minus 2 squared. Is that greater than or equal to 9? Well, negative 5 squared plus negative 2 squared. 25 plus 4. Yeah, that sure is. That's 29. That's definitely greater than or equal to 9. So that's why I end up with the idea that all points greater than that distance, that radius of 3, are part of our exterior. And the way I show that on my graph is similar to what we did with inequalities for linear equations. I just shade everything outside of that circle to show that all of the points outside of the circle, not just 0, 0, but all the points outside that circle would be part of that exterior. All right, let's do one more. Let's try x plus 2 squared plus y minus 1 squared equals 4. We'll make it a relatively nice one here. So my center, x minus negative 2 for that piece, is going to be negative 2 comma 1. My radius is going to be 2. I'm sorry, I'm talking inequalities here. I'm just going to go less than. I want to see what happens when I try less than. Not less than or equal to, just less than. So if I'm thinking about what's happening here, what we said before, less than would tell me less than my radius away. So all my points less than 2 units away. That would think interior of the circle. But I don't have the or equal to. Well, remember, the equals part was the part on the boundary. So the equals gives us the boundary. This less than gives us the interior. But there's no or equal to, so that means I don't want to include the boundary. So I'm going to do like I did with inequalities when we were graphing linear inequalities, and I'm going to put a dotted boundary to show that it's the boundary, but it's not included as part of my graph, part of my set of points. All right, so here we go. Let's see, I'm going to look back. X plus 2 squared plus y minus 1 squared equals 4. Okay, so my center we said was negative 2, 1. There's my center. Radius was 2, so that's a point on my circle. Now remember, let's be careful. We don't want to include points on the boundary. So I'm going to do my best. And these are a little harder than even the solid ones to get to look nice. But I'm going to put in a dotted circle to show that's my boundary, not included as part of my graph. And then I'm going to shade inside because the interior points would make that inequality true. For example, the center, negative 2, 1, negative 2 plus 2 squared plus 1 minus 1 squared. I keep putting those equal signs in there. It should have been less than, was from our previous slide. Less than 4. 0 squared plus 0 squared is definitely less than 4. That's true. That works. It's a point in the interior of our circle. So there we've got the difference between interior, exterior of circles. We're all set for today.